In this video, we are going to learn how to plot points, functions, and parametric equations. And some of these things we'll learn how to do in a couple different ways. And is what I want to do is maybe just start us off with how do we plot a point? So you would think after what we'll talk about next, you would think that you could just use the plot function like this, plot 2 comma 3, and you would see a point. Okay. And let's go ahead and hit run, and we'll see that we see nothing. Okay, it is just a set of axes, and there's no point here. I don't see 2 comma 3 anywhere. So to fix this, we need to just select a marker style. So I'm going to choose a point here, but you could use an asterisk or several other options. And you can actually find that in the documentation here. We could type in plot and select the documentation for plot, and we could scroll all the way down, and you're going to see actually a few different tables on here that will be helpful to you later on. One of the tables here is going to tell us the different types of line styles. So if we're plotting a curve or function, marker styles, what we want right now. Okay. We see these various different options. And also you can change the colors. Okay. All right, now let's go back. Let's get out of the documentation here. And let's plot this. But as what you're going to see is the point's going to be fairly small. Right, so if you want to change the size of the marker, you can. We can say marker size. And yes, that does need to be a capital M and capital S. And you can mess around with the size here. 20 is going to be a pretty big marker, but the point is we want to be able to see it right now. And yeah, we can see that. Okay. You can also adjust the color. Okay. If you decide to adjust the color right off the bat here, you could actually put it with the marker right here. So I can put R for red and then the marker style. Notice if we hit run, we see it's red. But another way you can do it is you can go to the end here and you could type in color, and then you could choose whatever color you want. And you can just do R for red, or you could actually type in the word red, and there it is. Okay. Now, let's say we want to plot several points. And so maybe I'm going to choose maybe several different X values. Let's say 1, -2, 3, 6. That should be plenty. And I'll choose the corresponding Y values. And how about we say -3, 4, 8, 1. So I just really chose kind of random values here. Um, and if we want to plot these, we could just say plot X comma Y. Okay. And before I hit plot, I want to point out that this should be plotting the point 1 comma -3, -2 comma 4, 3 comma 8, and 6 comma 1. Okay. This is going to do something actually a little different than you might expect. So let's hit run. You can see it's actually connecting all these points with lines. Okay. So if we just want to see the points and not the lines, again, you need to specify the marker style. And there's actually something else we need to make note of here in a minute. But let me fill this in. Marker size, and let's just say 20 again. Right, and so now you can see the 4 points and no lines connecting them. So by default, plot will plot the points that you have, but then it connects them with a line. And the other thing I wanted to note is that you can't actually see the original point that we plotted, the 2 comma 3. So if you want to continue putting multiple plots on the same graph, you just simply need to use the word hold on here. Okay? And now we'll be able to see all the points. You can see all 5 now. All right. I'm going to get rid of our hold on, and because we're going to overwrite this here in a moment. So let's say we wanted to plot something like y equals x squared. So is what I'm going to do is I'm going to kind of do this wrong first, and then we'll look at the better way to do this. So let's say we wanted to plug in the x values. How about 0 to 5? Okay, so this little vector I've typed in 0:5 is just going to output the numbers 0, 1, 2, 3, 4, 5. Okay, and if we want to see that, we certainly can. We could hit run here, and it displays down here in the command window the 0, 1, 2, 3, 4, 5. Okay. Now, if I want to plot this, I could type in y equals, let's say, x squared minus 3x plus 1. And so there's actually a few things that I don't like about what I've typed in here at the moment. One of them is I need an asterisk here for the multiplication. And when it plugs in x here, it's actually plugging in a vector. It's plugging in the vector 0, 1, 2, 3, 4, 5. Okay. So MATLAB's not going to be very happy about the way that we've typed this in. Let's hit run and see the error message. Okay. So you can see it says error using the caret. Incorrect dimensions raising a matrix to a power is an issue. So we can vectorize this by just simply putting a little dot right here. And now it should have no problem computing those y values. Okay. And so you can see our x and our y values. Okay. So now if I want to plot this, I can just do plot x comma y. So you can see it looks a little jagged here, right? Well, this is because we only use 6 points, 0 through 1, counting by ones. We can get more points here. We could say 0:0.1:5. And now it's going to give us all the x values from 0 to 5, but with the spacing of 0.1. So this will use many more points. I'm going to suppress this because I don't want to see the vector this time. And let's go ahead and give it a plot. And you can see it looks pretty smooth. Another thing that sometimes bothers me about plotting here on MATLAB is sometimes it's kind of hard to see the lines here because they're pretty skinny. But you can bump up the line width if you choose. I could say maybe line width 1. And again, you can adjust these values a little bit to see which line width looks best for what you're trying to do. Okay. So you can see that's a little thicker, but we could increase this a little more. Let's see. Okay. And now maybe it's too thick, but you can see it. We could adjust the color again. And you can actually, here at the beginning, you could just type in, say, red again. Oop, that's not an R. And this will turn it to red. But you also have the option to do this at the very end. But then if you do this at the end, you do need to specify color and then type in the R, and we can see it. All right, I'm going to get rid of some of these settings here. So we've seen that we can do it this way. You can also create this vector of x values using something called linspace. It's a little different. So we could say x equals linspace, and we could go from 0 to 5. And by default, linspace gives you 100 values. So if we hit run, this should look pretty smooth. Let's do that here in a second. So it gives us 100 values between 0 and 5. Okay. And looks smooth. If we were to maybe change this setting here a little bit, maybe to 10, we'll see that it won't look so smooth anymore. You can see some little jagged corners there. All right. Next, let's try and plot something using something called fplot. So we've seen how we can plot using plot. Let's use fplot. So fplot is nice when we have an inline function. So if we say rewrote our function here, the x squared minus 3x plus 1, using this notation, I'm just typing this in here now. All we have to do is say, hey, fplot of f, comma, and then give the domain. So we could say 0 to 5 again. And if we hit plot, here it is. And you can see again, it's back to the line being skinny because I haven't messed with the line width. It's blue, not red. So this graph here is coming from that f plot. Now, another thing you might be wondering how to do is how do we plot multiple things on the same graph? And we did mention that it was hold on, but now it might be a little easier to do two plots here at once now. So let's do hold on. Let's do g equals at x. And let's just do sine of x. Okay. And then we'll go back to f plot. We'll do g, and let's do it over the same domain, 0 to 5. And there's both graphs. And again, we could mess around with the color or the line width. You can also label the axes. You can give the graph a title, and we can actually also make a legend. Okay. So let's do that. Let's maybe label the x-axis. So we'll use x label. And we need little quotation marks here. And let's just simply write x-axis because we're not working on some application where we can say, oh, the x-axis is time in minutes. And we'll do the same thing for the y-axis. Let's say y label will be the y-axis. There we go. And let's also put in a title. And let's just say graph of quadratic and sine. We can hit run and let's take a look at what we have. And you can now see the title up top. You can see the x-axis is labeled with the word x-axis and y-axis with y-axis. But let's also put a legend in here. That's the last kind of important thing that we can do. And so is what the legend is going to do is it's going to tell us which graph corresponds to kind of which color. So the first one that we plotted was the quadratic. And the second one that we plotted was the sine function. And so let's hit run and we'll be able to see a legend. And you can actually move this legend around if you want to. So if it's blocking an important part, you can move it wherever you want. Right. So it is what we'll do now is we're going to look at maybe a couple more plots. And as we do that, we are going to try to put the plots side by side rather than on the same graph here. So we could actually use the functions we already have up here. But I'm going to give us some different ones to do. So let's maybe get rid of some of this stuff we have here. Or at least comment it out. Let's comment it all out. There we go. So next is what I'm going to have us do is try to plot a parametric curve. And let's just say sine, and let's say side by side. All right, so is what we want to do is specify the domain for this parametric equation or parametric equations that we're going to be working with. So why don't we use linspace? And why don't we say maybe 0 to 20? And I think I'm going to want more than 100 points to smooth it out. Let's just say 200. Next, let's type in the x equation. So the equation for x here is going to be t times cosine of t. And I'm going to suppress that. Y equals t times sine of t. And we will suppress that. And we could plot this right off the bat, but is what I'm going to do is I'm going to write in here um, the word subplot. We're going to try and do these side by side. So if we're graphing two things side by side, then we're graphing them in a 1 by 2 grid. So 1 by 2. So one row, two columns. And this is going to be the first graph. And so I'm going to use plot x comma y. And you know what? Since we're going to make a second plot, let's use fplot for that for the next one. Okay. So I'm going to write in here subplot again, and we'll do 1 comma 2. So again, this is part of this same 1 by 2 grid, but this will be the second graph in this 1 by 2 grid. And yeah, let's do fplot. And another way that we can do this without typing the inline function at the beginning, like we did with sine of x before, is you could say at x in here, and then just simply type in sine of x. But we do want to specify the domain, which we're going to use 0 to 20. Okay. So let's see what this does. We hit run. Oh, we have an error. What could it be? Well, we are multiplying a vector times a vector again, right? Because t itself is a vector. So we just need to put a little dot here. We'll run. And there's our two graphs. We have our parametric on the left and then our graph of sine on the right. And you can actually label these. So after the first plot here, if we want to put in an x label and y label, we can. Let's just take our x label and y label from before. I'm just going to get rid of the comment there. Okay. And so if I hit run, we'll see that this will just label the first plot. Okay. Which is good because maybe we want different labels on the axes for each one. Okay. However, again, we're not working on some applications, so let's just call this the x and y axis. I'm going to give the exact same labels down here. Okay. And so everything is labeled now, at least in terms of the axes for both graphs. Okay. But we can go in and we can title these just like before. So we could say title and parametric. And down here, we could fill in the title and we could just say sine, run. And we have the titles up there now. But you could also still use hold on. So like say we wanted to plot a point here with this parametric equation. Down here with the subplot, 1, 2, comma 1, we are going to add in one more thing. So let's put in a hold on, and let's put in a plot of, again, a single point. Let's just use the origin. Then the dot marker style, and let's make the marker size kind of big. Let's go to 20 again, and we'll hit run. And there it is.